All right, welcome everybody to today's tips and tricks in regarding the assemblies and basically how to do some time-saving techniques. My name is Yaku, so I'm not going to present anything. I'm just here to assist Carla with the introduction, and then she's going to do the rest for us. Just a few things, well, only one thing regarding the questions. If there's any questions, please feel free to ask the questions within the chat itself, or you can always just send us an email afterwards after the presentation, and then we will gladly assist you guys and come back to you. All right, so yeah, it's basically regarding assemblies, and I know from experience, especially with your large assemblies, it's sometimes a headache to open your assemblies. And then just maybe something from my side also, whenever opening assemblies, try not to open it through the network, but rather make sure your assemblies is local so that you can use your computer's performance and not your network speed. All right, that's just some small thing from my side. Now, I've got a joke, and yes, bear with me, I'm really not good with telling jokes. So for the joke that I've got is, we don't say that we are opening large assemblies anymore. So that's going to be something that we're going to stop. So we're not going to say, I'm going to open large assemblies anymore. It now needs to become, I'm going to start scheduling large assemblies. Right. So, and then that is hopefully something that Carla's going to cover for us. And then maybe this is not going to become an issue with us anymore. So then we can just open up assemblies without having any delays. All right. And then one last little joke is opening large assemblies. So there's 5 steps when opening your large assemblies. So step 1 is obviously you need to double click the assembly to open it. Right. Step 2 is then you will need to make some coffee. Then step 3 is you need to drink your coffee. Step 4 will be you're going to start questioning your career choices. And then step 5, the last one, it is still loading your assembly, so it's still not opened. All right, anyway, that's from my side. So I'm going to give it over to Carla. All right, thank you, Carla, and you can carry on.
Thank you, Yaku, for that introduction. No, I definitely think we all have that same issue regarding opening assemblies, especially with your large assemblies. So just quickly to introduce myself, my name is Carla, and I am a technical assistant here at Cadmes. I usually help out with support. Some of you guys in the chat have dealt with me before. And yeah, I'm hoping that today I can teach you guys some cool tricks and tips, especially regarding large assemblies. Just quickly, so I switched my camera on for the introduction. However, I'm going to be switching it off. We have some guests from Rwanda. So regarding bandwidth and internet connectivity, I'm just going to be switching it off to avoid any delays. So let's get straight into this. Okay, so I'm going to focus on large assembly performance specifically today. I'm going to be focusing on a specific setting in assemblies just to show you guys what I'm talking about. This is my model that I'm going to be working on. The setting that I'm talking about is this large assembly setting that is switched on over here. Okay, so basically what that does is it reduces graphics quality while rotating, panning, and zooming. It disables resource-intensive visual effects like real view graphics. Just further on that point, you can still switch it on within your assembly should you want to use it. But as default, large assembly setting switches it off. It also lowers the level of detail during dynamic viewing. It delays or disables background calculations, and it turns off certain visual features that aren't essential. And that's like more your shadows and mirror effects and all those different kind of things. And then the point that I want to expand on specifically is the last point, which is called lightweight. I'm not sure how many of you are familiar with the lightweight feature in SOLIDWORKS. So large assembly settings loads your components as lightweight instead of resolved. Just a quick explanation for you guys, the difference between resolved and lightweights. Think of a large assembly as a book. Okay, so what SOLIDWORKS does is when you open it in resolved, SOLIDWORKS opens every single page for you so that you have access to every single page directly. Whereas lightweight opens the table of contents instead. So you still have access to each and every chapter. You can still go to every single page that you want to go to, but it just loads it differently. And then in more technical terms, to translate that for you guys, lightweight opens your components, your features, your sub-assemblies, etc., as more of a graphics component along with its mates, instead of opening the sub-assembly, all of its parts, all of its features in its entirety. Okay, so that's just a quick explanation. And then I just want to show you guys, I did a little comparison video where I opened the same assembly in lightweight and in fully resolved. So I'm just going to show you what the difference is between those two. I put a little timer here as well. Okay, so as you can see on the left-hand side, I'm opening it in a lightweight and the graphics loaded immediately. The assembly is already present. And in resolved, it took a little bit longer. And while opening it, you can see the difference in opening components on the left-hand side versus the right-hand side. You'll see the left-hand side is already on 3,000, whereas the right-hand side is only on 1,000 now. And I also want you to notice that on the right-hand side, on resolved, there's prompts that keep coming up. So those prompts are basically features that SOLIDWORKS is trying to recognize within the sub-assemblies and within the parts, obviously, that you now want to recognize. On the left-hand side again, you can see lightweight's already opened, you have access to your feature tree, and resolved is still opening. So, and this is quite a large assembly. This is assembly of over 6,000 components. So it takes a little bit of time. And this is also, it's quite a powerful machine. So yeah, just to show you that that definitely does work. I'm not going to let the video run in its entirety because it takes quite some time. So I'm going to take this exact assembly that I opened here, just to show you guys. Okay, so something that I want you to notice is in your feature tree, right? On these different sub-assemblies, on the little icon, there's a small feather which indicates that it's opened in lightweight. Okay, and the main assembly does not have a feather, so that means it's resolved. There is a way that in your large assembly settings, you can set certain sub-assemblies or certain parts to resolved instead of lightweight. Okay, that's very easy to do. You just go to your feature tree on whichever sub-assembly you want to use. You right-click on it, and in your settings, you'll see there's a set lightweight to resolved. Okay, so for the sake of this webinar, I have already set the part that I want to work on specifically to resolved. I have also set every single sub-assembly within the sub-assembly to resolved so that I can work on it. Okay. But let's say, for argument's sake, I did not name anything in my feature tree and I want to figure out where I want to work. Excuse me. So I know that I want to get to the inside of this little submarine. Okay, so I'm going to do, I don't know how many of you are familiar with your exploded view. I'm just going to take this whole thing apart for time being, just so that I can get to where I want to get to. What I want you to notice is that when I moved the part, I have to go back to the property manager to go click done in order for it to be in its place. However, just a small little tip for you guys. If you click on a sub-assembly that you want to move, and you move it to where you want it to be, and you just move your mouse cursor a little bit more towards the viewport, you'll see that there's an option that you can right click, and then that says done. So that's just a small little time saver that you guys can use. Okay, now I'd like to move this sphere. However, it is transparent, so you'll notice that when I try and click on it, it clicks the inside the seats, which is not what I want. So another tip for you guys is you can just hold it in shift, click in the same place, and it selects the transparent sub-assembly. Okay, I'm just going to move this little guy up as well, so that everything is nice and spaced out. Awesome. So there's my exploded view, and now I can get to where I want to be. Okay, like I mentioned before, I'd like to work on this specific part of the submarine specifically. So I'll go to this component. SolidWorks, don't fail me now. Okay, here we go. Awesome. So you'll notice that it opens in the feature tree, right? Which is typically the way that we would go and find our components, okay? And this assembly is massive. So I'm definitely not going to go through all of this to try and find what I want to work on. So another way that you can get to the assembly that you want to work on is you'll see the left corner here at the top. There's the sequence that we call breadcrumbs. Okay, when you go to each component and you select it, you'll notice that it selects the solid body that I selected. It selects the part when you move forward. Then it selects the component, and then the assembly, and so forth until you get to the main assembly. However, for the sake of this webinar, I know that I want to work specifically on this subassembly. So I'll right click on it. I'll open the subassembly. It's rebuild. Great stuff. My plan with this assembly is to take this component and duplicate it on this face. Now, I know that obviously there's a lot of different methods in doing this. So you can take the route of mirroring the face so that whatever cut extrudes you did on the left-hand side repeats itself on its right-hand side. Or you can copy each part of your component. You have to then remate every single one of these bolts. So you'll see that there's a mate here between this face and the actual bolt. You have to add your slots and all those different things. And then at the back end side, you have to make sure that everything is coincident, and you have to do all these different cuts where I know there's 5 different cut extrudes. So that's an incredibly time-consuming method. And what I want you to consider in cases like this is design intent. Okay, so this component specifically, I know, is repeated within many of the sub-assemblies, and the entire assembly as a whole, it's repeated like, I think 6 or 8 times. So every single time I have to go add this component, I do not want to edit every single face, do cut extrudes, do mates, do all those different things because it is so time consuming. So an easier, much easier method is we'll go to tools, we'll scroll down to make smart component. Okay, so what shall I call this is now? Okay, so in your property manager on the left-hand side, you'll see that I have to select the component that I want to repeat. And then in the components that I want to repeat with it, I'll choose the bolts because it repeats it with its mates and everything included. And then I'll choose these blocks at the back. Okay, now I want to choose the features that have to be paired with the component itself. So I'll go here, I'll select these holes and this guy over here. Okay. Right, everything is selected, everything looks fine. And I say, okay. Okay, so you'll see now the smart components in the feature tree has a little lightning bolt next to it. It also has a smart feature tab underneath it. Whereas if you expand that, you can see which cuts you've included. You can see which components you've included. And then you can also see your reference. So your reference refers to whichever face or whichever parts or extrusion or whatever you want your extruded cuts to or your features to be repeated in. So our smart component is created. Now we just need to save. Okay, it's done saving. Great. Okay, so this is the face that I want the component to be repeated on. Okay, so I'll go back to my feature tree and select my smart component that I've created. I'll hold in Control, left click and drag. Okay. As you can see, it's obviously not facing the right direction. So another cool tip that I can show you guys is you right click, hold right click on your component and you turn it instead of having to turn your assembly in its entirety. Okay. Need to position this correctly. Awesome. Okay, now yet another cool tip for you guys is this component I'd like to be coincident with this face. Okay, but let's say it's far away, or whatever the case may be. You hold in Alt on your keyboard, and then you just drag it to the face that you want to mate it with. And then it mates, and you make sure that it's coincident. See, if you do smart mates, right, it gives you these options. You can still choose whichever, if you want to do a distance mate or you want to do an angle mate, whatever you want to do, the option is still there, but it's just smarter and it's a little bit quicker. But we'll see now how it works with the distance mate. Okay, so now it's coincident. I'm happy. However, it is not positioned correctly. So I want it to be exactly parallel to this one. So I'll just go to my Evaluate tab. Measure. Sorry, this screen keeps popping up on the other screen. Okay, let's just remove that one. So I want to know what the distance is between this face and this face. We work on normal distance. So that says 15 millimeters. So remember that. And then we'll choose these two faces just to know that distance is 32. Right, we have our distances. So now you have one of two options. You can click on your one face, shift, click on your other face, and you can do a distance mate of 15. Just make it go the other way. Ah, there we go. Awesome. Okay, or you can do exactly what I just did with the Alt, drag to that face. And then the options pop up again, where you can choose distance mate. And I think that was 32, if I remember correctly. Ish. Okay, that happens, it's fine. We'll just go to mates. Okay, just switch it around. Awesome. Okay, so now we can see our component is inserted. However, the bolts aren't there, the blocks aren't there, the holes aren't there. So we click on our component, go to the feature tree, we right click, scroll a bit down to insert smart features. And then this little window pops up to show us more or less which face we need to choose as our reference. So we already know that it's this one. And there we go. Smart component inserted. Right. So you'll see there's your holes, the bolts, everything is inserted. Another cool thing I want to show you guys. Let me just find the original. Here it is. Okay. So let's say for argument's sake, I want to add another component to this face over here, right? Okay, I'll insert it that way. Just make it coincident to this face. And let's say, for example, it's a little bit skew, but you don't notice it at first. You'll go insert your smart features. Okay. Give it a second. It's fine. Great. So let's say that you've done this and now you know you need to move this component. Okay, so it's coincident with the face. So you can move it however you want to. However, you'll notice that the holes and other features are left behind. Okay, so you move your component and all you do is you do your rebuild or Control Q. And then your holes move with it. No, I can't see in there. There we go. There's your holes. Everything is included. Just hide this for you guys so you can see. Right. Now, I just want to delete this thing. Yeah, this feature tree is getting way out of hand. So another cool tip for you guys is if you want to collapse your entire feature tree, you just do Shift C. And then your entire feature tree is collapsed. Okay, but I now want to go delete this guy over here. Eat. Oh no. SolidWorks has left the chat. I call this feature random rebuild or no random exit. Oh no, I was done with that in anyway, so it's fine.
Carla, just from my side now, I was actually hoping, I was actually not hoping, but I'm glad it crashed because then I could do another joke for you guys. So the one is, congratulations, your last half an hour of work has been converted into a learning experience.
Yeah. And I have time to rethink my design
Exactly.
and my career choices. Oh no. Okay, it's fine. This happens to all of us. So when this happens, what's nice about it is that we've already saved our smart component. So when you try and open the assembly or the sub-assembly again, you'll notice that the smart component is still there. So that's great because you have to save it in order to edit it. So I think I've had enough of smart components for now. I want to show you guys some cool patterns, pattern components. So I have this chain over here that I'd like to run on this track. This is quite simple, actually. It's not going to be very intense. So you go to your assemblies, you go to your linear component pattern, go down to chain component pattern. Okay, make sure that your method is selected to 2 links because we've got 2 links over here. Then for our chain path, you'll see that there's this track over here, but it is drawn in different lines. So what I want to do is I want to go to my selection manager. I want to make sure that the closed loop is selected. And I want to fill my path. Okay. And select. Otherwise, you have to go to how many instances you want to repeat, and that's a whole mission. So just fill the path. Okay, so for chain group 1, I'd like to select this blue link, and I want to make my temporary axis visible. You'll see here in your property manager, there's 2 options. You have to select 2 axes. Okay, so the first one will obviously be the front, and the second one will also will be the back. Okay, I'm mentioning this. I know it sounds obvious, but I'm mentioning this because it's very relevant for the second link. So just bear with me. Your path alignment is wherever you want the track to run on the link. So you'll expand your link in your feature tree. Luckily for us, they've already drawn a center for us. So we select that. Then we head over to our chain group number 2. We select this link. And now this is where the obvious part comes in that I mentioned earlier. Your front axis has to correlate with your front axis of the previous link. And the same goes for the back, obviously. Did it select now? Yes. Okay. And the path alignment plane is the same. It's going to be the center. Great. So that's more or less what it's going to look like. I'm happy with it. Full path. Everything looks fine. And we click OK. Here we go. There's our little chain. And it moves. So that's very cool. Okay. I just want to close my other sub-assemblies. Otherwise, this thing is going to crash again. Don't save. I have another cool pattern-driven component to show you guys. It's more of a linear component, a linear pattern, sorry. But I want this component to rotate. So let's see how we're going to do that. Fairly simple. Same option. Just drop down the linear component pattern. We'll select a linear component pattern. Okay. Now I want to select whichever direction I want this component specifically to be patterned on. And obviously I want it to go upwards. You'll see at the top here, there's an arrow that shows you which direction the pattern is going to be repeated on. Okay. Then distance, from what I remember, I think it's 240 if I'm not mistaken. And we'll do 6 components. Okay. We also want to rotate the instances, but I'll show you that just now. I just want to show you what happens if I don't click rotate instances. So this is the components that I want to pattern, right? So I mentioned I want to repeat this blade, and I also want this part at the bottom of it. I want it to be repeated. Okay. Okay, so it seems like 240 was not right. Let's do 250. That seems a little bit better. Okay. So as you can see, this specific component is patterned like linear in a linear pattern, but I want it to rotate. Okay. So I'll click rotate instances, and then I just want to click the face that it needs to rotate around. And then I need to pick my degrees. I think I picked 30, if I remember correctly. There we go. Everything seems fine. However, what I do want to mention is that I know I chose 250 for the spacing, but I can clearly see that there's some interference or collision here. So we'll check that just now. Let's just click OK for now. I chose the outside face. That's funny. It's fine. We can just go and edit it. Rotate. Don't want that one. I want this one. There we go. Right. Okay, so let's quickly see. I mentioned the interference. So I just want to see where exactly and how much I need to move this assembly up. So we'll go to evaluate in your tabs at the top here, interference. We'll make sure that the assembly in its entirety is selected. You want to make sure that your selected components isn't just one component. Otherwise, it's going to say that there's no interference. So you need to keep that in mind as well. Okay, and then we click calculate. And there's our results. We can clearly see that there's an interference there. And it'll be the same for each one of these instances. Okay, that's just a cool tip. That's actually not the model I wanted to show it on, but I did notice this while modeling now. So let me show you guys quickly how I would do this on a different model. Over here, I actually have a moving component where I think interference detection and collision detection is a little bit more relevant. So you can see that this arm rotates, and it rotates these two parts over here. So let's start off with a interference detection, right? So you can see that it's moving, everything seems fine, but just for my sanity. We'll see if there's any interference. So let's calculate. And there's interference. And we can see it's between this part and this part. And if you click on the actual interference in your results tab, you'll see where the interference takes place. Okay, so now that I have that, I do want to mention that if there's interference in an assembly, that doesn't necessarily mean that there's going to be a collision. Okay, so let's just have a look once again for sanity check to see if there's any collision that takes place here. So we'll go to our assemblies tab. We'll go over to move component. Okay, in your property manager, underneath options, we want to choose collision detection. We want to make sure that all components need to be checked. And whenever there's a collision, I want to know that the face is going to be highlighted exactly where the collision takes place. Okay, there's also the option for sound, but I don't know if you guys can hear anything that's going on my screen. So let's see if this works. And there is a collision. Okay, so this is now a completely different problem that we have to figure out quickly. So what I would like to do, I know obviously on the inside edge here, along with the inside edge here on this part, there's a collision and an interference that takes place. So I'll go and right click on my part and open it in a separate on its own. Sorry, just see what's going on here. Features. This is fairly simple. I know a majority of you guys already know how to do this. We'll just insert a chamfer to make it run nice and smooth. Okay, edit it. Okay, just rebuild it. So our chamfer is inserted there, which is great. And then we want to go to this part as well and do the exact same thing. Okay. Back to our part. There we go. That seems better. But just once again, for my own sanity, I want to make sure that there is no collision that takes place. So we'll go over to move component again, collision detection, all components, and I want to highlight my faces. And there we go. Smooth sailing. That's great. That makes me happy. Awesome. And that's it for the collision detection and interference. Lastly, anything regarding large assemblies can get quite confusing, especially, I mean, I showed you guys the submarine that I worked with earlier. That feature tree can get out of hand very quickly. And you are lost and you don't know what to do and you need to go out and search for things. And it just gets frustrating and it's time consuming and you don't know what to do. So let me show you a few quick tips and tricks just to clean up your design tree a little bit. Just make it a little bit more organized. So I've got this very cool chest set, and there's a variety of different components here. Firstly, we have our board. We have one king, one black king, one white, one queen, one and two horses. You know, obviously you guys know how chess works, but whatever. So what I want to do is I want to group these components so that I have access to them individually, in a group. So I'll go and right click on my assembly as a whole, move down to my tree display. Firstly, let me just show you what this looks like, right? If I expand this feature tree, there's a ton of things that's written here. We've got our instance count, we've got our numbers, we've got quantities, we've got everything. So I just want to clean it up a little bit so that it's not that confusing. So I'll go to right click on the assembly, move down to tree display and component name and description. Sorry, this window keeps popping up on the other side. Okay. Primarily, I'd like the component name to be there. Then I don't really want the configuration name, and I don't really want the display status. This window is now not opening up properly. Okay, so we just click apply and okay, and it takes away all that confusion, unnecessary things. Okay, then just to group everything, we'll go and right click on our assembly again, go to tree display, we'll go to group component instances. Just make that active and then click in your viewport and you'll see your design tree is nice and cleaned up. You can see your white pawns. There's a quantity of 8 and then you have your instance count of 1, 2, 3, 4, 5, 6, 7, 8. Same with the black pawns. And you've got your 2 bishops, 2 black bishops, 2 white bishops, whatever. Obviously, the king and queen is in its part only because there's only one of them. But yeah, and then that is it from my side in terms of that.
But yeah, then have a good afternoon, everybody.
Yeah, I hope you guys enjoy the rest of your day.